Hey folks, want to make another video as kind of a follow-up to my TDC video from a few days ago, kind of outlining some of the methods that I do to gather data without having to rely on the map tools here. So I tend to, when I play sim games like this, I try to kind of understand how these guys did it in real life and try to replicate those procedures. So I've spent a lot of time reading the historical KTBs. So those are Kriegstagebücher in German. Those are the war diaries that were kept by each boat during a patrol, and I can safely say that I have a pretty good handle on how these guys ended up gathering their data, and it didn't really involve any of the tools that that you would see in the scope, okay, in UBOAT. So in this particular case, what I'm going to do is I'm going to spawn a target and just demonstrate a day engagement against this particular target. So just bear with me here. We're going to we'll spawn one here and then kind of see what happens. My understanding is it's supposed to spawn. There we go. Okay. All right. So then that spawns there. That's a little too close for comfort. So what I like to do is I typically run out of visual range. So when I do an engagement, you can see obviously we're taking an alarm hit right now. Typically when you're out at sea and you're just traveling along and you come across chimney smoke or whatever, I just very cautiously approach until I can literally see the ship through my own eyes. Not wait till they're this close. I think this just spawned this close, but typically that's way closer than I would get. So I'm going to open the range to the range that I normally would do this exercise at. So just bear with me here. We'll just assume him because he's already on the UZO. We will see what we have here. Yeah, you can see that's way too close. I want to get them so they're pretty much hull down. So we'll accelerate until that's the case, and we'll accelerate until our discipline hit goes away, because the reasoning for that is this is somewhat artificially silly how this is currently implemented, where, you know, if an unarmed merchant ship is in sight, you know, chances are your guys aren't going to be going wild because of that. So I like to actually prevent that from even happening by just getting so far away that that it's basically not even an issue anymore, and that means to the extent of just, you know, letting the mast tips be visible. And so you can see that's pretty much there right now. We'll turn parallel, what we think is roughly a parallel course right there, and then basically what we do is while we're at this range, we simply watch. We know that the angle on bow is probably pretty close to 90. It's certainly greater than 45, right? So we're gonna actually see if we can't match course and speed on the surface at long range and get all the target data that we need, and then maybe do a confirmation of it once we get around to the front of the target. But for now, what we're gonna do is we're gonna say, okay, you know, that's roughly parallel right there, but in order to ensure that we're parallel, I can see the bearing is moving astern, so we're going too fast. Alright, so we're going to bump it down to slow speed ahead. We're also going to watch to see whether or not that target appears to be getting further away or getting closer. Alright, if it appears to be getting closer, we are not on a parallel course. We actually did turn away. If it appears to be getting further away, we need to turn toward it. Alright? Well, this appears to be staying about the same size, but we're still gaining on him, right? So we need to keep bumping our speed down. All right, now he's gaining on us. Okay, So now what we can do is we can say, okay, we're pretty much on a parallel course, we think. It's really not getting any closer or further away from us. So we can safely say we're probably pretty much parallel. I'm gonna go ahead and just change this to 090, and then since we know think we're on a parallel course, what we're now gonna do is we're gonna try to measure its speed. And the way we're gonna do that is we're gonna pick a bearing, and let's just call it 280. All right. And we're gonna wait. We're gonna make sure our course stays steady or thereabouts on 090. And at that bearing we picked, which in this case was 280, our discipline hit should be going away. I'm not quite sure why it's not. Yeah, I'm not sure, but we're gonna wait till 280, and once we hit 280, we're gonna actually put a mark on the map. We're gonna start the stopwatch. Alright, so 280 is coming up here pretty close. And what we're basically gonna do is we're gonna just run alongside him for a while, and we're gonna measure the distance that we traveled. That's gonna be basically the same as his speed. You can almost think of it as like if you're traveling on the highway, when you tell your buddy, it's like, okay, let's meet me at this exit off the highway, and you are kind of going next to each other, and he might be going 1 minute might be going a little faster than you are, and then the next minute you're going a little faster than he is. Well, by the time you guys hit that exit, so 279, right? So I'm gonna just quickly start the stopwatch and put a mark right about where my bow was, okay? Right there. And I'm just gonna wait. So you can see how far out they are now, right? So now you can see our hit has gone away, and we're still tracking these targets at long range. That's what we want right there. That's the pattern we want. Discipline's going up, we're gathering data from far away. Anyway, so you're trying to arrive the same exit. You're going a little faster, he's going a little faster. When you finally get there 10 minutes later or whenever, you get there at the same time, okay? Your effective speed is the same, even though it fluctuated while you were on your way. This is the same concept here. We made one mark on the map, okay, and we're going to travel a certain distance, and then we're going to, after a certain time, stop the stopwatch, make another mark on the map, measure that, time, speed, distance, get the speed, and that'll be the target speed. It's important to be on a parallel course or very close to a parallel course when you do this. If it turns out that you're not on a parallel course, you need to bump that speed estimate up a little bit. Okay, so make sure we're still on 090. The bearing we're measuring is 279. So what we're basically doing is we're letting that funnel move back and forth here, and we're gonna bump our speed up and down such that bearing really just doesn't change from kind of this little circle right here. We always want to make sure we're within a couple degrees of the course we want, and that's 090. Okay, so now you can see he's dropping back a little bit. Right, so now we're going to bump our speed down and let him come forward now. Right, we're just watching, and I like to typically do this over 10 to 15 minutes. Just to save some time in the video, we'll do it maybe over 6, and then we'll pretty much call it good. But then also keep watching the mass tips in the funnel and see if they shrink or grow, because then you'll, even during this exercise, even then you might have to actually change course just to make sure you're still steering a parallel course. Okay, so that's important. Alright, so let him go a little further ahead. There he goes. Okay, now we're going to bump our speed up again. We're going to make sure we're still on the same course. We are. Alright, we're going to let him fall back again. Alright, now we're going to let him, and then we're going to drop our speed down again and let him catch up again. Always just going back and forth. Alright, and this one is going to catch up. Maybe at 6 minutes we'll probably call it, or whenever he hits that bearing again, we'll call it. It's going to be pretty close to 6 minutes. But when that happens, we're going to very quickly put a mark on our map, stop the stopwatch, and then put a mark on the map. Okay, so we're check 90 degrees. Okay, well, as soon as that funnel gets up to the cross, we're going to stop the time, we're going to make the mark, and we'll do some measurements. So that's it right there. I come down, I put a mark on my bow, would have been. You can really use any spot on there, but I just like to use the bow or close to the bow. Okay, so 6 minutes and 23 seconds. That's about 6.4 minutes. What I do is I measure the distance. All right, one cable is 1/10 of a nautical mile. I've got mine in nautical miles. So 5 cables would be 0.5 nautical miles. 7 cables is 0.7 nautical miles. So I have to do a conversion because I'm using, as part of the TDC mod, there's this table here. This table button, you can click here and you can actually get time, speed, distance calculations just at a glance. Okay, so, but it's in meters, so I need to convert it. So 7, I know there's 1,852 meters in a nautical mile, so I'm going to take, and I do 0.7 nautical miles, so 0.7 times 1852 gives me 1296, so call it 1,300. That's 1,300 meters in 6.4 minutes. So we look at 1,300, we go across 6.4 minutes, that's 6.6 knots. 6.6 knots is the speed. Okay, so right off the bat, we're going to go ahead and set 6.5, 6.6 knots like that, and call that good. Okay, go blue. All right. Oops. So that's that. Okay, so we've basically matched course and speed of the target. That's what we wanted. We are going to, at this point, we think we're on a parallel course, so what we can do now is we can actually get the TDC loaded with the course that we think he's going. So in order to do that, since we think we're on a parallel course, we set our bearing to 0, open the TDC. First of all, I want to get the lighting right here. This lighting is not right. I'll have you come and do it. Let's get the white light on. Okay, so so set it to 0, okay? Alright, and we want to set the AOB. Now at 0, if we're on a parallel course, when the bearing is 0, the target we're in front of us, the AOB would be 180, okay? 180. So we need to set 180 in here. So we say, okay, we set follow, matches the optics to the bearing. We set 180 as the AOB. Okay, just like this. We click this, and then we click Lagerlaufend. Okay, and then I click this off. Alright, so now I've got the AOB set in there, and it will, my own course changes will be taken into account. Okay. That's the advantage of doing this. Okay, so so that's kind of the deal with that. I've got that programmed into the TDC now. So at this point, we're basically just well, what am I doing? We're on the wrong side of the target here. So there he is. Okay, so you can see he's still about the same size. We're basically traveling a parallel course. All right. Okay, so now the key is to accelerate as fast as we can. Oops. And try to get ahead of them. Okay. And while we do that, we can actually get a better appreciation for what the target course actually is, and then we can apply a slight correction to our speed estimate if it was in fact different. So we're going to do this basically until we are exactly ahead of that target. And now to demonstrate the TDC, so we already set Lage laufend, we set the AOB in there, right? So now if I put my optics on the target, there we go. Now you can see that would be the angle on bow. Now, okay. Set that off again, just to make sure we don't screw anything up. That's a little fast. Okay, now you can see, update. You can see the AOB is changing. I just selected on and off, so don't screw anything up. Now, as I'm going around the target, I'm going to basically keep that mast tip, keep those mast tips about the same size all the way around. So I know I'm always about a constant distance away from that target. So you can see, yeah, see, that's getting good now, and they're shrinking a little bit. So now I maybe can start turning in about 10 degrees. We'll go, or maybe 5 degrees, go 0.85. Okay. Check the AOB. Okay, now it's saying it's going to be slightly less than 80. So we're working our way around. Always keeping that target about the same size on the horizon. Let's check the AOB again. Now you can see, yep, getting smaller. Once we know we're going to be ahead of him when the masts align. All right, now he's really shrinking, so we're going to go about 10 degrees to port. When those masts start lining up, that's when we know we're going to be ahead. So these guys would overhaul the target basically until they were exactly ahead. That obviously provided some advantages, one of which was, it gives you the most flexibility of maneuver. When you're exactly ahead of your target, that target can maneuver as much as it wants. You're likely still going to catch it. 2, it gives you their exact course line, so you'll know for sure what the course is at that point. And 3, it actually allows you to plan your approach by knowing that course line. You can basically move off that course line the set distance that you want, and plan your attack. All right, so let's go update. So he's looking to be about 55 degrees right now. So we're working our way around him. Yeah, it's good to get the AOB set in the TDC like this, so you can always just go blue off and just check to see how that angle on bow is progressing. You could leave blue off all the time, but again, I've run into problems with the AOB getting all screwed up, especially if I have to mouse wheel out of the optics for whatever reason. I've had it get all scrambled up on me. So use historical behavior and do the blue light whenever you're coming off the target. Okay, that's going to be good here. We can go to 55 degrees. Yeah, we probably don't need flank speed anymore. Yeah, it's really nice to not be taking, discipline hits at this point. Limit of visibility stuff going on. Just always keeping him nice and far away. Speed check. Coming just under 40 now. Okay. Blue. Gonna be about right. So once we get on his course line, I'll show you also a little trick to confirm the speed. Basically do the same thing but ahead of them, and you can do your plotting. He seems to have disappeared completely now. Entirely sure where he went. Turn in a little bit. There he is right there. Oh, okay. Yep, so he disappeared pretty quickly on us. So we need to be careful to not, you know, to not lose him that quickly. So let's even slow down to slow speed ahead. So we're going to be approaching the, zero here pretty soon. Right now it's 20. So we don't want to lose him again like that. He disappeared pretty quick. Whoops. Alright. We said 6.6 knots. Getting pretty close. Getting pretty close to zero. You can see the maths are almost aligned now. Very close right there. Yeah, see, this says 10 degrees. Alright, we can start turning onto the course. Ever so slow, slightly. Right now he disappeared. Let's stop, let him come back into view again. There he is right there, okay? So we're pretty much on a parallel course right now, or he's about 5 degrees, AOB of about 5 or 3 degrees right. So, so actually his course is about 0.95, to be honest with you. Yeah, course about 0.95. Okay, so we can true the course up a little bit. Just like this, and then we'll do should be 0 at that point right there. Oops. Okay, perfect. Alright, we true the course up like that, and then we oops. Okay, there he is right there. Okay, so now we can check the speed again. We can kind of do the same exercise. We can do the timing. So we can say we think we're pretty much on a parallel course right now. We can say slow speed ahead, and then we can wait until well, we could do slow speed ahead like that, and then wait until he disappears, and then we can bump our speed down again, mark our position. Almost. Okay, now he's... Okay, not quite. He's not quite gone yet. Wait till he disappears. Alright, now he's gone. So we can come in and do the... and do this. And then start the stopwatch. Now we can drop our speed down. Wait till he comes back in view again. There he is right there. Perfect. Alright, he's back in view again. So now we'll speed up again. Get him out of view again. Now he's out of view again. Now we'll slow down again. This is actually easier to do ahead of the target than it is the other way around. Alright, slow down. Okay, now he's in view again. Now we'll speed up again. Now he's gone again. Now we'll slow down again. Alright, there he's in view again, right there. Okay, so we can stop the time, we can mark our position, which is going to be right about there. So 6.3 or so minutes. He went 6 cables, 6.3 minutes. So again, we can do the conversion. We can say 0.6 times 1852 is about 1100. So we can go 1100 at 6.3. So 1100 at 6.3. At 6.3 is 5 point, right around 5, what about 6 knots? Okay, so we could say, I think before when we measured him, we had 6.5 knots. Okay, and I think that's right. Yeah, we had like 6.5 knots when we measured him last. We didn't quite have the course exactly right, And so his speed was actually closer to in the upper 5s. Okay, so we can even split the difference, just call it like 6 knots, and we probably are close enough. Okay, so that is that. Alright, so now the other thing we want to do here is we know we're pretty much on its course line, or very close to it. So what we do is we can really decide what side of the target we want to attack from. So the sun is that way, so we're going to attack from that direction. We want to attack out of the sun. All right. So what I want to do now is I'm actually going to go about half speed ahead, and I'm gonna turn and try to cross the T, cross his bow, and then as soon as I cross his bow, I'm gonna make a mark on the map, and then that'll be where his course line is, that I know his course line to be. Alright, so let's get eyes on to him. Okay, where is he? Not sure where he is now. Let's turn to about 000. Should put him about on our on 270. Just disappeared from view again. Okay. So that's going to put him at about our 270. Close to it anyway. Yeah, we lost sight of him, but that's okay. Oh no, there he is right there. Okay, so we're going to wait until he's perfectly zero. And when he's perfectly zero, we're going to make a mark on the map, and we're going to run, we're going to dive, and then we're going to run that far off of his track. So he's not quite at zero yet. Almost. As soon as those masts and funnel are perfectly aligned, we know we'll be at zero. Alright. Almost there. It's pretty close right there. So now we can make a mark on the map, and we want to run a set distance off of that point. We can actually order a dive now. Periscope depth. Okay, and then we can mark off the map, or off that amount anyway, the amount that we want to run. So let's run about just under a nautical mile. It's going to be about 18 or 1900 meters. And we'll call it good. Okay, so that's what we're going to do. We're going to try to run that distance out. Alright. So okay, I'm going to run that distance out. And then once we're that distance, we're going to turn in. Okay? We're going to turn in. Turn down toward the target. And approach him from on a parallel course. Okay? So we're almost there, so we even start turning now if we wanted to. Alright, we'll turn 90 degrees. Okay, so here we go. Turn 90 degrees. Alright, now we will assume skipper. Let's take a look. See what we got here. We should have him. Now the handy thing is at this point is since we're on a parallel course, and actually his course is 095, so we need to be actually we need to be at 275, not 270. 275. Okay. A little different. Okay, so I don't want these guys on the. I don't like them raising that while I'm doing stuff. That's crazy. Okay, so we're gonna look for him. He's gonna be pretty small because he's still gonna be coming over the horizon. But he should be a couple degrees off of our 0 at this point because he's so far away. There he is right there. I see his mast tips. Okay, so now his angle on bow is going to be equal to the bearing because we're on a parallel course. So I'll be about 4 degrees left. Okay, just like that. Alright, so now what we do is we simply just close the target. We wait until he gets close, and we eyeball. Oh yeah, there's 2 of them. Okay. There might even be 3 of them. So we'll see. We basically just approach until they really start coming out. When they really start coming out, then we need to be judicious with our speed and with our scope usage. Okay. In the meantime, let's have our mechanics start preheating the torpedoes. We're going to be pretty close in these shots. That's good. That's what we want. If you ever want to know how far you are off of their track, take the current distance and multiply it by the sine of the angle on bow. I don't have a feel right now for how far we are away, but if your scope is 1 meter above the surface, so like right here, then the horizon is about 3,500 meters away. Meaning, when the ship's hull is fully out, looks like it's fully out of the horizon, it's about 3,500. So you can see if I put that about 1 meter up, which is about like that, it's not quite there. They're probably about 40 to 4,500 meters away. So if I use that information and say 4,500 meters times the sine of the angle on bow of 5, that's going to give me a distance from track of 300 meters. Okay, that's pretty damn close. It's almost too close, but we'll go with it. Okay. The other thing I like to do is I didn't do this, but I like to have him oh, I don't need him on. I need him doing heating. Okay. I got my chief engineer on the depth steer station. That literally was his job. Battle station was or diving station, both diving station and battle station was at the planes. The fact that you have to tell him to go there in this game is one of the things that irks me about it, but it's a relatively minor detail. So, okay, we're going to keep going. It's going to be pretty damn close, almost too close, but like I said, we'll make it work.
Alarm! Aufgefechtsstation!
Okay, yeah, there we go. So now we get the alarm. Okay, let's just check the AOB again. actually going to turn off just a
Jawohl.
little bit because I just don't want to be too close. And I'm going to bump my speed down. Oh yeah, there is that third one right there. Okay. Just to open the distance off the track a little bit, I'll do this, and then I can actually turn back to 275 parallel.
Zu Befehl.
Okay. So this is looking good. Okay. Yeah, so far so good. So this guy here is, I put us about a meter up. You can see that the hull's almost completely out now. It's probably about 4,000. Let's just see what the actual range is, just for argument's sake. Yeah, so 1.7 nautical miles is 3,000 to that guy. That's, let's see. Yeah, 3,000. Okay, 1.9 times 1852. All right, that one's 35. Okay, so they are actually pretty close. They're 35. Okay, so 35. So distance from track 35 at a angle on bow of 15 is 900. Okay, so that's perfect. 900 meters away from the track. That's the distance from their course line. So that means when I turn in, I can afford to run in a little bit and get nice and close. I don't like the fact that this guy is so far ahead. It's going to make it difficult to shoot him. But alright, let's see what we got here. We got those two. Let's see, 3.
Aye, aye, Herr Kaloi.
Alright, we could turn in. So we'll turn 90 degrees.
Jawohl.
Bump our speed up just to keep the speed up in the turn. Alright. Go. Okay. I can throw the scope up again. Okay, well we can try to shoot him. So right now we're on a perpendicular course. Okay, so if I look at the AOB here, you know, I can now do blue light or blue off and get an AOB. Now again, here we had a little problem because we changed course so much. That AOB is not valid anymore. So like if I look at these ones, for example, see, and they're not valid anymore. So it's changing. I think there's a limitation how much you can change course maybe with this. But we know we're on a perpendicular course right now. Right, our course is, yeah, 90 degrees from their course, so we can set it to 0. We can set AOB 90 left. Let's just reset everything. So 90 left. Click, boom. Okay, and now we're all set up. Okay, now we can set the range to what we think it's going to be, and then we can wait for these guys to cross the wire. Now, how we know we're closing correctly is we watch that bearing change. You can see we're gaining on that target a little bit, so we're going to more on a somewhat on a collision course with him. We can't go any slower, however, so our targets are going to be this guy and this guy. Alright. It's going to be pretty close. This one here. Yeah, 80. Yep, looks about right. Yeah, the gyro angle is practically 0 on that one, so we'll go ahead and shoot both of these guys now. Alright, so here we go. Let's go ahead and flood tube 1.
Rohr 1, bewässern.
Depth 3. Perfect, okay. Now we can...
Rohr 1 bewässert.
His range is almost going to be close to 900 to 1,000. Alright, so we will go ahead and shoot him.
Los!
And then let's flood
Rohr
tube
2,
2.
bewässern.
This guy's significantly closer. Okay, right about there.
Rohr 2 fertig.
And let's go ahead and shoot him.
Los!
Hopefully by me moving the scope off that didn't screw it up. I don't think it would have, but... okay, and then we can go hard right rudder.
Jawohl.
And then, let's just see what we're looking at here. Should be looking pretty good. Let's check the... Yeah, so you can see that's going to hit center mass pretty much right there. Little aft of center.
Schiff wurde getroffen. Schwere Schäden am Rumpf.
Yeah, okay. Now this guy... This is going to be... Yeah, he put the brakes on right away, apparently, when he saw everything.
Feindliches Schiff wurde getroffen.
Yeah, that got hit. Okay, that's good. So then we can say... we'll turn in and we can try to shoot this guy.
Rohr 3, bewässern.
See what he does. Approach him bow on.
Rohr 3 bewässert.
That guy's going down. This guy is questionable. Oh yeah, that didn't... So we will go ahead and center the rudder,
Zu Befehl.
and then we'll see what he does. If he turns bow on, yeah, which he's going to, so what we're going to do is we're going to go left full rudder. We're going to have him heat up number 5,
Herr Kaloi.
and we are going to take a stern shot at him.
Bestätigt.
It's going to be freaking close. Alright.
Sehr wohl, Herr Kaloi.
Alright, here we go.
Rohr
Flood the
5,
tube.
bewässern.
Bow left 80. Range minimal.
Rohr 5 bewässert.
Speed, bump it up a little bit. Alright.
Los!
Oh, shoot, I forgot to set the parallax. That's not gonna be a valid shot.
Zu Befehl.
Yep, that's not good. Always remember, if you're gonna shoot the stern tube, to set the parallax to your desired tube, because I sure screwed that up bad there. You're gonna see that that's not gonna do anything, because it's went out of the wrong end. So okay, so let's see if we can swing around as quickly as we can here, so we can still get a shot off at this guy.
Sehr wohl, Herr Kaloi.
Okay, so here we go. We want bow tube.
Rohr 3,
Flood that one.
bewässern.
Bow left about 120, 115 or
Rohr
so.
3 bewässert.
About 6 maybe. Okay. Perfect. And we will go ahead and shoot.
Los!
He's turning away. I tried to lag him a little bit, so we'll see what happens. Okay, should be good. Okay, there he goes. Alright. So that's that guy. Where'd everybody else go now? Got wreckage. Yeah, this guy is still chugging along. Let's see what he's at. Oh, yeah, that's the guy we just hit. Right. Alright, let's see what he does. Yeah, well, he'll go down eventually. We'll help him out with another eel.
Bestätigt. Ei, Herr Kaloi.
Okay,
Rohr 4, bewässern.
alright. Speed 0. Nothing else matters.
Rohr 4 fertig.
Okay.
Los!
Goes. Oh, and he's gone. Okay. Well, that didn't take long. Alright, so anyway, that's that. Just matching speed, matching course and speed on the surface at long range gives all the data you need without having to touch any of these tools over here. That's pretty much what I wanted to show. So, and just kind of what a day approach would look like, and using the TDC in conjunction with that. So, hope you guys enjoyed it. I'll see about maybe doing a night engagement for the next one. Alright, thank you. Bye.